Welcome to Counterintelligence, and congratulations on getting this far.
Sorry. Let's start the review for the pair exercise. So in the first one, we need to read the message from this README file, this secret README. So there's a read method we're given, and we need to pass in README. The important thing to recall is that this will return a promise, so we need to await it if we want to console log the result. Let's separate this out into two lines, actually. Let's call this our README, and then on the next line of code, let's console log it. Okay. And so we need to figure out how to get the report, but we're going to get through this in steps. So first of all, the marks. Let's see. We need to read the bios of A, B, and C from our dossier, as it were. Dossier? I don't know. And then we need to console log those things in whatever order. So if it's whatever order, then let's go with something simple and follow the pattern we had above, where we console log the result of awaiting read of dossier A, and we'll just repeat this. So we're going to do that for B, and we'll do it for C. And this happens to be in serial order, in sequential order. We could have done it in parallel too, but I know there's an exercise next that will do that for us. Ooh, the plot thickens. So down here, the infiltrators. Now what we want to do is make sure to read SPY A, B, and C in parallel. And to do that, that means we need to make sure that our reads, so let's do SPY A, B, and C, that we call read one after the other and don't await any of them before calling the next one. Because if we call read immediately, the promise gets constructed right now, and the asynchronous task gets kicked off right now. And then later down the line, we can await them. And one way we could do that, let's just call this, this will be our A promise, this will be our B promise, and this will be our C promise. Now afterwards, we can go ahead and await the promise.all of A, B, and C, and that comes back with an array of the resolved values, our spies. So now let's go ahead and console log those spies. There they are. If we don't want to log this in an array, and if we do want to actually capture each result from this array, we could do spies 0, spies 1, spies 2, and then we would at least sort of see them all. Instead of in the array syntax, we would see them all logged out in there. So that's fine. But this pattern of accessing the 0 and 1 and 2 value of an array, this is a little inconvenient, and let's make it slightly more inconvenient. So I'm just going to call this SPY A equals spies 0, and then we're going to repeat this for B and C. So this might be something that you want to do, and that's why we want to go over it here, because you might want to capture each result from this promise.all. And I want to show you another way. So here, it's still working the exact same way as before. So another way we can do that is with destructuring syntax from ES6. So over on the left-hand side where we assign this constant, we can actually say, nope, the constant itself is an array, and I'm going to declare kind of a sub-constant inside of that, where the first element should be called SPY A, the second element SPY B, the third element SPY C. So this means we can avoid this spies 0, spies 1, spies 2 thing, and just capture those constants directly from the array that comes back. So notice we have array brackets where we would normally have a name for this constant. And then inside of the array brackets, we have the names that we want to assign to each element of the resulting array. This is unrelated to promises. We can do this with any kind of array, or async await. We can do this kind of destructuring syntax if we have any kind of array. So now let's talk about the key. This one's a little different because we don't want to console log. We actually want to return something. So in this case, we want to return reading the key. And we can put an await here. It's interesting. We could actually exclude it, but let's go over that at a separate date. So here we want to return awaiting reading the key. So that's fine, except that it tells us there might be an error. And in case that it fails, we want to go ahead and say, try it. Try doing this. If it fails, catch that error. And we don't actually need the error, so I'm gonna catch it, but we're not actually gonna do anything with it. And instead, we're gonna return this default key of 5 Hanover. So, oh, we're not actually logging the key down below. Yeah, we could change that pretty easily. There. So now the key shows up as 5 Hanover. I'll just put a new line in here as well, so that we see it on the new line. There we go. 5 Hanover shows up where we want it to. Okay, so that's our key. Notice that what we're doing is reading the key, but if that fails, just returning 5 Hanover by default. Down here in the report, this is where we're going to do a lot of really interesting stuff, because we're going to combine a lot of pieces. So we first need to get the length. So this is something we know how to do. We can await read report length. And that comes back with something we'll call length. Why not? Now we want to do some kind of loop where we go through, and for I is 0, so our index, while it's less than the length, we're going to read, ultimately, here let's do a template string, report /I. So this thing we await, and that's going to give us a line, as it were, a single line from this report that we want. So we need a place to put that. Let's do report equals an empty array and push each line into it. Then at the end, we want to concatenate it all together. So that's going to be report.join. And since these are all different lines, let's put a new line character there so that it shows up in different spots. And we can return that, because that's what needs to come out of the report function. So let's do a similar thing down here. I'm realizing this won't be console logged unless we do something about that. Also, we can just put a \n at the end of that string. All right, so let's run this. Oh, it's upset about something, missing parens after the argument list. Right. Okay. So now we have an issue here, and this is something that we didn't deal with yet. Some lines are redacted, reading them will fail. And there's nothing we can do about it. So instead, we should replace them with just redacted. That means that we need to do a try here. So we're going to try getting the line and pushing it, but if there's an issue, instead we'll just push the text redacted. So we want to make sure that if there's an issue, we put redacted there. And now if we run it again, okay, now we see the message showing up down below. That's what's right here. Yeah, looks very, very interesting. Now, make the drop. In make the drop, we combine some asynchronous methods that we've used. So we need to call our own the_key method. And here's what's interesting about the key. It looks like it returns a string. It doesn't really, because it's an async function. So it actually returns a promise for a string. That's what comes out of this thing. So because it's an async function, when we see a return in the body, what we should actually think is, the key function returns a promise that resolves with that value. So down here, we could actually await the result because it's a promise, and that will give us our key. And this is how async and functions are composable. We're building make the drop right now, and we're awaiting a different async function we built. And we're also going to await our report. to get the report. And then finally, so we got both pieces of data from those, and now we need to do some kind of a write operation. So looking at how write works, there's a little bit of documentation up here. We give it the path, and that's apparently COINTEL, and then the key, and then the data. So we're going to write to /cointel. I think of it as COINTEL, and then we're going to give it our key, and then we're going to give it our data, which is report. And we should await this as well, because this is a promise for updating some file somewhere. Let's run it again. All right, so we're doing pretty well, except apparently the key we used was too old and reportedly leaked. You might have been exposed. So the extra credit assignment here is that we should read the key until we get some kind of valid response. So we're just going to do it over and over and over again. This isn't always a good thing to do, but it's good to know at least how to do it. What I'm thinking here is that what we could do is use this function recursively. So here's our extra credit take. Let me comment this out for a second. We're going to start with the same idea, which is return await reading /key. Now, if it fails, that's in our catch. This is kind of our base case in a way. And if it fails, this is our recursive case, as in try again by awaiting the key. Just call this function again, await its result, which when it finally succeeds will be the proper thing, and we return that. So we're going to create a recursive call stack that should eventually resolve with the proper key. Assuming it succeeds at some point, it'll succeed. Okay, yeah. So this is the extra credit, what we have down here. Extra credit. And this is pointing us now towards this bonus exercise.js. Before we go on to the bonus exercise, let's just do a little bit of wrap up here. So what we're seeing here is how we can use await to perform a single asynchronous operation, many asynchronous operations, many asynchronous operations in parallel by capturing the promises up front, then awaiting all of them together. We see how we can have a default answer, or an answer in the case of an error, by doing a try catch. We can also do looping with await and with try and catch, and more complicated logic where we're pushing to an array and at the end joining it. And finally, and this is a really good takeaway, if you're creating asynchronous functions and using them yourself, know that you should await them to get their resolved value. So the key here does not return a string. Even though in the function body it looks like it returns a string, it actually returns a promise for a string because it's an async function. So we have to await it. And that's how we can compose them together. Let's go on to the bonus exercise. Bonus exercise is quite a doozy. So we're going to need to, it starts off not super different than what we've seen already. We're going to need to loop through all of our double agent files, which is 0 through 9. So for I is 0, while I is less than 10, we will keep going through it. And we will read agent/I. Okay, apparently some of the reads will fail, so that's telling us that we're going to need a try here. We'll figure out the catch in a second. But we want to console log these agents that we find in any order. So for now, I'm going to console log. I'm going to await reading here and console log it. Now, if there was an error, it tells us to retry in the case of a 503. And what it means here is to retry one time, not over and over and over again. So we just need to say if the error, and I believe it's going to have a status property of 503, which is a thing we can get somewhat used to with Express. If it has a status property of 503, well, try again. And I'm just going to copy the exact same kind of code down here to try again. And if we wanted to, we could make this into a function called try logging that we would do here. I am going to actually capture the, I guess, the file path thing, because that's repeated. So that in both places, we can just say file path. Okay, so let's try this out. Let's see what it logs when we do bonus exercise. Yeah, I mean, that seems right. We could try to check secrets.js for the agents if we know where to look. So if we can look into the source code of this thing. Let me toggle linting off. This is just distracting. So Angolds, Martins, Lim, Fox, Bear, and Hama. Yep, those are all of them. And notice there were some that were just not found in there if we look at agent again. So we have some not founds that we're just ignoring, which is good. It tells us to ignore those not founds. Now the schedule. Okay. Yeah, this one's for real. This one takes no prisoners. So we have to start by reading /schedule/tmv. That's going to come back with text. That text is JSON. We need to parse it. So here's, at the very least, a sort of first blush at this. We read it. That comes back with JSON text, or I'll call this a JSON string, if we await it. And then we can apparently JSON.parse that to turn that JSON string into actual information. So let's JSON parse this JSON string and just console log to see what it looks like. All right, so the very first one comes back with data. It's an object with data and next, and that's what this is telling us as well. So if we read, we get a string. If we parse it from JSON, we get an object. Just to be clear, if we don't parse it, here's what it looks like. I'm just going to get rid of the other one for a second. Notice it's going to look like an object, but if I do the type of this thing, it's actually a string. So this is actually just text that looks like an object. Until we parse it, it isn't actually an object. So for example, if I try to get JSON string.data, that would be undefined. But after parsing it, if I've got an object and console log.data, that will exist. All right, so this is the structure of our data. If there's a next key, we want to keep reading and concatenating it. Yeah. So we're going to take this data and ultimately add it onto what we want. So it sounds to me like we're going to want some kind of loop here. Okay. Here's what it sounds to me like. We're going to want a loop where we start off and our schedule has just a next property. Yeah, which is just this piece of it. Because I notice that, here, let me comment this out for a second. Notice that when we console log it, it has a next property, which is just not the /schedule part. So we're going to want to start off our schedule that way and say that, oh, maybe this is better as a while loop because our incrementing condition is kind of strange. But we're going to keep going while schedule.next exists. And then our condition for how we choose the next schedule, this one's actually kind of tricky because what we're going to do is attempt to JSON parse and get the next property of it. So yeah, why don't we do this as a while loop? That sounds fine. So we'll just do let schedule equals this thing up above. And again, that's not necessary. It's just, I think, going to be more readable. And we'll say while there is a schedule.next, well, then we'll keep doing the following code. So in here is where we're going to have this read, only this part is going to be based off of our current next. So let me make this a template literal and replace this part with schedule.next. So once we get this JSON string back, well, we could have also failed, and that's important to note. So let's actually do let JSON string down here, and we're going to try to assign it. and apparently it might fail. Just like above, it might fail with a 503 error. And if that error is a 503, we're going to try one more time. JSON string equals, and then we do an await. I am, as before, I am going to do a file path variable up above, so we don't need to keep repeating ourselves with the same file path. There's our file path. All right. So, okay, so now we attempt to assign the JSON string. And if we have successfully done so, then at the end of this, we should have a JSON string. If we have not done so, if we have not successfully gotten any information, then to me, that means that we should break. So if JSON string is undefined because we never managed to assign it, then we'll break out of the loop and we'll be done cycling. The other possibility is now going to be down below, and that means that it's time to do our JSON.parse on it. And this is going to give us back our schedule object, which we can now reassign based off of the next. We just called it on the first JSON, so on the first next we just called it, but when our loop goes again, we'll call it on that schedule's next. Also need to make sure to take the schedule data, and let's see here. It contains data. We need to concatenate them all together. And we'll worry about the UTF-8 thing in a second. Let's call this our, this is our message text. So it's an empty string at first. And what we're going to do is message text plus equals schedule.data. So we're just going to keep adding and adding and adding onto it as we go along. Eventually we'll leave this while loop, and that's when we want to console log the message text. Let's see how this goes. All right, well, we got something, but this is now the base64 part. So a base64 encoded string is just one way to store text. UTF-8 is another way to store it. Base64 is maybe a common way to store our files if they're not going to be human readable, but we need to convert it to UTF-8 if we need it to be human readable. So I looked this up beforehand, and one way I found was to use a buffer constructor. So to convert this string into a buffer that's in base64, and a buffer, you can imagine, is kind of like a stream of binary data. The important thing about it isn't that it's a stream of binary data or anything, but it allows us to convert between string formats, which is kind of nice. You can imagine we're sort of converting the string into some lower level piece of information to sort of its binary representation, and technically an octet, and it allows us to convert it to a string of a different kind. So we'll do toString UTF-8. So this buffer class has a toString method. And this is the way that the format we're going to parse it, pass it in as, and this is the format it's going to come out as. So this is our actual message, human readable message, as it were. So let's console log this thing. And there it is. It's telling us the schedule and then the secret knock-knock code to get in there. These bonus exercises are pretty challenging. I think a good takeaway from this one is that you can, you can catch and do a specific thing in your catch. So you might test if the error has a certain status and do things under that case. I think that's a really good takeaway from the above one. The one below has a lot of different logic going in on it. There's something fundamentally very similar about what we have above, this try catch. Some other interesting things we did, though, was we saw a pattern where we had this .next property, and we keep going while it's there. This probably reminds you a little bit of linked lists, and this is something that you very well might see if you run into different kinds of proprietary data storage or things like that, where you run into different ways that people might store data. So it's cool to see another way to loop through information that isn't just looping through an array. We're sort of going until we hit a next that's null. that has been the pair exercise on counterintelligence.